I've got a simple plastic 3D printer at my disposal, but I know how to work with larger companies to get metal parts or more stronger parts made in other materials.
Awesome. That's huge. It always seems like you have to mount either sensors or motors or different pieces, and there's a lot of brackets and different pieces that need to be made.
Definitely. And I hope I can be of assistance in that way here. So.
Awesome. Hey, Howard. Good seeing you. Can you hear okay?
Oh man, oh my god, that's easy. Let me turn on the videos.
Well, we can hear Howard, whether you can hear us or not.
Is in and out. Good evening, Al.
Buenos dias. Did you shoot Bambi in your backyard yet?
No, sir. Howard, you want to do a mic check? I think Howard was going to do like an interpretive dance for a presentation tonight. Was that?
Sorry, I just have my volume turned up. Sorry, I cannot do any presentation. I saw the meeting thread, the meeting online. Someone already did a ROS2 presentation, and
we could always use another.
I don't think I have anything more. I didn't do that much of research. I'm just reading. I'm just watching the ROSCon for a while, like the last year's ROSCon, and actually I have my colleague working on ROS2 together with me, and we're forming a group in my university to talk about ROS2, and we probably will switch to ROS2, and probably not because I haven't compiled anything yet, successfully yet in ROS2. And here's my colleague Sena Hangde. You met him before during the competition.
Awesome, great seeing you. Good. How are you guys doing? Are you ready? Are you planning for next year?
Well, Howard's doing the planning, I think, as of right now. So I think Howard has more to say to that.
Yeah, unfortunately, he quit. He's a quitter. I had to work on my thesis. So
is that a Baxter back there?
Project. Sorry?
Is that a Baxter in the background?
Yeah.
You should take a tour of the lab.
Yeah, I should. Okay, I'll give you guys a tour in the lab, and if that counts to my presentation today. Okay,
we'll take it.
Okay, that's a Buster, and I'm not sure who is working on this, but I'm not. And there's a Fetch.
Okay.
Yeah, that's the humanoid robot that we're working on, like mainly in this lab, and it's supposed to do everything. It is a firefighter humanoid robot, and we're designing something else. Like we're replacing all the aluminum parts with 3D printed structures. So we have a lag finished already. That's a lag.
Wow.
Yeah. It's all 3D printed with ABS. Oh, I believe it's PLA for now. But I think it will be switch ABS. Well, yeah, that's well, there's this robotic arm. I don't know what's it called, but I think I saw it like a lot of places. And Wanjian Tech is the designer for this Darwin. Let me grab it.
Does that read emotions and do different things?
I'm good. Yeah, that's a Darwin, and it can kick a ball. I think that's all it can do. But it's a really good developing platform for robotic things. Yeah, that's about it.
That's great. That looks like fun. Lots of things to play with.
Yeah, it is. And for my master's thesis is to work on the motor controller. Actually, I'm working on a microcontroller that controls the motor controller of the humanoid robot. Basically, I'm designing the lower, like the base level control system for the humanoid robot.
Okay. Did you guys participate in that Atlas competition on Mars where they had to move the robot around or the humanoid around?
No. I don't recall which one you were talking about.
Okay. Are you going to write all of your motor controllers in ROS 2? Is that why you're studying that?
Well, for high-level control over the humanoid robot, I'm not sure if they're gonna use ROS2 because no one in the lab have experience with ROS2 yet. But for ACBOT, for a competition next year, I think we're going with ROS2. And also, I know that ROS2 is supporting the real-time operating system RTOS, and I'm planning to use TI RTOS on my microcontroller. So that can be embedded into ROS2, I think. But I'm not sure about that yet.
And when do you graduate?
I'll graduate with 2 majors. Let me talk outside so I don't interrupt my colleagues. I'll graduate with 2 majors. I'm working on my 2nd major, and in a year. And then I'm already working on my master's thesis, so it will take me another year for my master's degree. So I'll say about 2 years. If everything goes well, I will be graduating in 2 years with a master's degree and 2 undergrad degrees.
Fantastic. And that'll come up this fall, 1 more year out?
Sorry?
You have 1 more year left?
For undergrad, yes.
Okay. Great. Thanks for the tour.
Thank you.
For tonight's meeting, we kind of wanted to work in a safety topic. I don't know if anybody had an area in agriculture robotics for safety or robots in general and safety that they wanted to talk about.
I can keep talking. Yeah, I can talk about some safety feature we had last year for the competition.
Okay, so what do you think about doing like a public demo with a small robot, like a lawn tractor sized robot? If you were out in public, what type of safety systems or would you need to have set up?
I want to say definitely a remote control emergency stop that you can hold in your hand just in case something happened. You can cut the engine right away with a remote you hold in your hand. And people can see you're holding the remote, so they'll feel safe to be around with the robot. And I don't know if, right, like that, yeah. But I don't know if a computer vision system is an overkill for a lawn tractor. But what we did for the competition last year, well, this summer, is to have a camera in the front, and it's running a machine learning algorithm that detects all these kind of objects like human, dog, cat, cows, cars, like this. And when it sees something in the front, it will stop.
Was that the DNN object
Right.
classifier package?
Yeah,
Okay.
we use the MobileNet SSD as the framework.
Okay. Excellent. We caught Howard's introduction, but I want to get back to Chris's introduction and maybe a little bit about what you're working on at your farm.
Hey, hey everybody. I'm Christopher Knudsen. I guess my family has a farm out in Iowa that started out with my great-grandparents, and then my grandparents and my dad grew up there. And I'm an engineer for the government here in the BC area. And I specialize in additive manufacturing, particularly with the kind of industrial AM. So just making parts out of sintered aluminum or titanium or stainless steel. But I also have a small 3D printer here at home and do CAD design and all that kind of work. With the farm, it's out in northern Iowa and currently has conventional soybeans and corn that's used for ethanol. And our family's goal is to eventually turn that farm into an organic farm. Still trying to figure out what to produce, and I'm still somewhat new to the whole agriculture world. Everything that I know I've learned from my dad. But I try to go out there every year for several weeks and learned about some of the basic farming techniques. But our goal is to make this farm as automated as possible. And so I would really like to help support this initiative with my additive manufacturing kind of experience and capabilities. I can help people fabricate brackets and parts like that, but also eventually can help maybe test out some of these technologies in a field. So I'm very new to this. I actually just learned about this organization about an hour ago, and Matt introduced me to the Slack channel. So I'm here to help and here to learn.
Awesome.
I think we
Great
could
to have
use
you.
a
Thank you for joining
titanium
us.
gear.
Excuse me?
I know exactly where we could use a titanium gear to
Oh yeah?
steering mechanism and an electric motor.
Well, I might be able to help with designing it. I don't have a titanium printer that I can print on for a project like this, unfortunately. But I've got connections, and I'm actually currently a master's student at Penn State, getting my master's degree in additive manufacturing. So we could maybe use their machines for printing the metal parts. But I can help with designing.
Show your steering, your coupler that you use to couple your 12-volt motor and the steering gear. Come on.
I told him, Al, if I show it to him, he won't come back.
Oh. He's telling you were doing exactly what Jeff told you to do.
I did exactly what Jeff told me to do. It works.
I'm just messing with you a little bit, Chris. Welcome. You said you're going to Penn State. Are you in Pennsylvania or?
So it's online with some in residence programs. I'm currently in Maryland, just about a mile or so outside of DC.
Cool. We're not too far away. I'm in Pittsburgh myself.
Oh, okay, cool. I've got some friends who live out there. Well, anyway, I really do look forward to helping support this initiative. So please link me in on the Slack conversations if there's something where my expertise might be helpful.
Can you see the bracket?
Matt is about to demonstrate greatness.
Woo!
I think you did a pretty good job putting that together. I think a 3D printer could probably make it a little bit more robust. And,
yeah, but that wouldn't be any fun.
It's very
I
cool.
thought there were only rednecks in the South, but Matt said, no, that's a Spokane redneck design.
Yeah, limited tools, limited skills in that area.
Well, I'd be glad to help.
Awesome. I do have like a little community update, couple of slides we could go over. You know, when you do the screen share and you have 20 windows open, it's hard to figure out which window is going where.
First world problem.
First world problems. Okay, can you see this? I suppose. How about that?
See it.
I can see it.
Okay, so just a little bit of a community update at Ross Agriculture. We're creating an ecosystem to empower farmers with robotic tools. It's a focused initiative of the robot operating system. And last year, we started out with the ambitious goal of creating an open source self-driving tractor. So we teamed up with Open Source Ecology and went out there and built this micro track. And we laid out the components to automate it, but we never finished the automation portion. It turned out it was a little bit more difficult to automate that machine. So we still have the goal. Our goal from a year ago or 6 months ago is to create a software stack that people can download and then automate a vehicle. We switched over a couple months ago to the lawn tractor platform, which is pretty small. It's a small platform, a little bit safer, but still has enough power to do real work and a lot of attachments. Right now we can drive the machine around, so it's automated. It's listening to command velocity message from Ross. Al was able to log into the Raspberry Pi that's on the tractor through a VPN. The next step to work on localization and then maps, and then Al or anybody else could drive this robot around remotely, and we can practice different techniques. Are there any questions about kind of where we are with building the software stack or along this project line?
I just had a question. This is Walter. On when you think of like Ross, right? This interface, and you're having the communication messages, and you're joysticking it, right? And it listens to command velocity. Is there like I know you guys have been talking about the RMAP or MapViz or something where it's like the, I don't want to use the word like main control window, but basically like this is where you can manage each of this one vehicle or couple of vehicles. Is that part of our architecture plan? And what does
yes, it is.
The mechanical in the room?
I didn't catch that last question about the VPN.
And I was just wondering if maybe our additive manufacturer knows what VPN means, but just in case someone on the call does not.
Okay, that's good. So no, reduce the amount of acronyms, but the virtual private network, that allows a remote person. So on your computer, you can log into this lawn tractor and it's just like it's on your network. So you can plug a joystick into your computer and then connect to this lawn tractor and drive it around. And as far as the control station, the two ones we were looking at is RViz and MapViz. But it still needs a little bit of work for MapViz. RViz, you can drive the vehicle around and send it waypoints to where you want it to travel.
So if you're using that VPN, does that require a third-party server, or can you just connect it with what you have?
Al may be better able to speak to that.
We were using a free for up to 100 devices service by, you can find it at, I think it's zerotier.com or tier0.com. I can find it and look it up. And we were getting...
So it does require It does require somebody else's service, though. You can't just connect your computer to another computer. You have to go through someone else. Is that how that works?
This particular one did. I mean, there's probably, I think Kyler is using one that's sort of open source and doesn't necessarily require a third party. These guys have made it just easy, and we were still getting, I think we were checking the ping times. If people are familiar with that terminology, the latency, the time it was taking to get commands back and forth was 150 milliseconds, which was, you know, pretty darn good for, you know, going from well, in our case, Pittsburgh, Pennsylvania to Spokane, Washington.
Okay.
We haven't tested the latency from Zimbabwe to Spokane yet. There was one question about the different components that we're using, and I kind of break the components down into 4 categories. I've got hobby, commercial, industrial, and military. So there's different grades of components that you want to use. The goal with this lawn tractor is to make it as low cost as possible. So we're using things like the Raspberry Pi for the computer and a little teensy for the microcontroller, potentiometer, and a little pickup sensor for the wheel encoders. So these just teach you the basic, these are hobby grade components, and even on the GPS probably will be hobby grade. But as we learn more about automation and we move to bigger projects, and depending on your specific need, there are parts and components, they just cost more money. As you move up the scale from hobby to military, the price goes up exponentially. Is there any more questions about the community project?
And were you guys still working on the, I mean, I'm not sure the best, it seems like the less command windows you have to open, the better, but I know it's still early dev. Is there, and you were talking about that Docker image at one time, or some image you could just download and use. Any progress on that? Thought, feeling still?
Yeah, so there was some discussion around that, whether we should use something like a virtual machine, like Ubiquity Robotics makes a virtual machine that's their control station. But the vote is to go natively, so we'll run on actual hardware for the base station.
Right, which is still good, but I think even having those images pre-built might be helpful. Is that part of a discussion point, or just on the bottom because it's still getting to the point of actual, I mean, you guys are controlling it, but I mean, more usability. So like somebody could just take it, put it on buy the hardware, download it, not have to compile 35 hours, but just put the image on and run.
Yes, yeah. But Walter, we haven't really, we need more and more, you know, people to go through the system and set it up to streamline it. But to install ROS locally, we've been using the Lino Robot ROS.me script, and it'll go out and install ROS on your local machine for you. And then on the Raspberry Pi, that's just an image from Ubiquity Robotics. So that's a pretty easy setup.
Oh, perfect. That's awesome. Cool.
I wish, Walter, but we're not there yet.
Not there yet.
Well, I got these 80-hour weeks where I'd be able to help. I'm just asking because that's an easy thing to do if I had the time.
Okay.
I mean, the nervousness about how long it takes to go from scratch to, you know, a fully operating navigation stack is valid, obviously. The instructions that I've written and that are put out there, I can go from, you know, imaging a laptop to having the navigation stack installed in probably 2 hours is about how long the process takes at the moment.
Wow. All right. Game on.
That's impressive. So for the last few months, I've been working on corporate community partnerships. Now, in an open source community, it's a little bit the lines between the corporate and their what if you want to do commercial robotics versus the community. There's a little bit of a blurred lines, and we're still trying to work out what parts the corporate or the corporations want to open source versus the parts that they don't, and then how we can work together. So I've been contacting this company in the UK called Earth Rover, and they build agriculture robots, small farming robots. They applied for a grant. We applied for a grant, a Rawson grant, and they fund ROS software development. And they were awarded the grant, and so they're putting together some different pieces and like our input about the software and the platform. And so they wanted to work on a specific phase 1 for milestone 1, and the thought is around open source outdoor localization. So we'll put together a robust localization package that we can use. Any thoughts on Earth Rover or questions or?
Who got this grant?
Do what?
Sorry, my phone's weird. Who got the grant? Who's working on that?
Earth Rover. So it's a ROS grant. ROS Industrial Europe has $3.4 million to give out for ROS development. And every quarter there's an open call for, it's called a Focused Technical Initiative or project, Focused Technical Project. And Earth Rover was awarded to open source the software and hardware for their robot. So ROS Agriculture and Earth Rover will be working together over the next 15 months to open source different portions of this robot.
Oh, wow.
Go ahead, Walter.
I was just explaining awesomeness. Sorry.
I mean, as far as input goes, Matt, I mean, taking Husky, putting it on an Ackerman vehicle, having the same instrumentation stack as we're likely to have, I mean, getting all that to work, I mean, that's the next challenge we have. So if they could help, that'd be fantastic.
Okay. I have a meeting with them on Thursday, and so we can, if we like the outdoor localization, recommend that we support that.
I mean, is there any challenge that you can give them to try and do it without GPS? Everyone's like, oh, GPS, I know, but I'm just asking.
That's a great question. I'll ask them what they want to do for GPS degraded areas or denied areas, and maybe we can work out something where it can fail over to a GPS denied type of localization.
I can't really see what's in that, what the crop is in that field they're driving around in. It could be that it's a small enough field they could put up markers so they could have some kind of landmarks they could look at as they drive around. Or in the fact, once their plants are up like that, you can use a camera to follow the row. You don't need necessarily GPS. Seems to me that GPS is important when you're planting something, you have no crops coming up at all. And once the crops come up, you need to have something that follows the rows of crop anyway. So if you have a camera or a laser or something, they can see the plants and follow the row. So it seems to me that, you know, initially GPS is very important to drive a straight line, and once you get past that, it may not be as important. And also, if I look through this website, it's going to tell me how the robot works. I'm trying to get a view here of the robot, and I'm always interested in how they do their motors and their frame and all that kind of stuff. So I'm just curious. There's a little video, but I haven't watched the video yet. So I'm just curious if you've looked at that hard enough to know what's in there.
That is one of the items that they're going to open source is the hardware and the motors. But they have a GitHub account which has some drivers and some software, but I'm not sure if there's the plans for the hardware base.
Okay, and it could be if I go through the video, they'll give me enough pictures that I can see what's going on. And yeah, I just haven't done any digging at all yet, so I just curious if you knew.
That little robot has 4-wheel steering, so that's been a interesting. I haven't ran a vehicle with 4-wheel steering, so that'd be kind of different. It's double Ackerman, not 4-wheel steering.
Hey, are you guys familiar with Turtle Rover?
No.
So this is kind of a cool little project right here, and this is open source as well. It's more meant just for like a rover you can drive around, but there might be some aspects of it that could be useful for what we're working on here. It sort of reminds me of the Earth rover.
Just pulling up now. I haven't looked at that one. Does that run ROS? The Turtle Rover sure sounds like it should run ROS.
I don't know. It's all open source.
Okay.
From the initial picture, you have to watch out. It looks like it's attacked this guy. It's grabbed him on the back and it's trying to kill him. Either that or he's just carrying it around like a backpack, maybe. So.
Let's see.
It already has a picking arm.
So it's got an app that you can use with a tablet or something like that. Uses Raspberry Pi.
It's surprisingly quiet on the software that's in the controller.
Yeah. Well, they have. If you go to the tab that says Turtle Rover on it, and you scroll down, it says Learn What's Inside. If you click on features, you can see looks like a Raspberry Pi, but then there's a controller board on top of that. And I'm still not as familiar with this technology as you guys are, but you can see a motor controller, I think, above that. There's the. Okay. Not sure that's anything. That looks like the electronics that are inside there. I just sent that out to everybody on the chat function.
That's a cool robot.
Looks like a differential drive. Is it Ackerman? It doesn't look like Ackerman.
It looks kind of like it's a trimmed down Mars rover. So instead of having 6 wheels, it looks like it has 4 wheels. So it could be that, you just simply, it's like a skid steer type thing. I haven't dug through, so I'm not sure here what they're doing.
Anyway, might be useful for all this. I like how the design's modular and that you can add different attachments to it. It looks like they've got a version with an arm on it. They've got a version with the Xbox Connect on it, and with like a hoist on it, and then a SLR camera. And so I'm kind of curious to see kind of how they structure their this technology. So it's modular.
They have the code posted, and I think it's not ROS. I don't think they're running ROS.
Oh, okay.
I've just been looking over the main electronics box assembly, and that's awesome. I like how they show how each of the connectors and the parts. Neat design. definitely some ideas that we could use and take from that. Thanks for posting that link. One last item. We'll get that. North Star Robotics. So if you are interested in a commercial kit for your robot, they're working on an automation kit, and we can get access to that, early access to that automation kit. So there are some, we could be beta testers, or we could do other things. So we're still trying to understand how the community can work with corporate partnerships and what we can do to help them, and how we can work together to create more of a collaboration. So at this point in the game, the goal is to at least get everybody to be able to make a self-driving tractor. Out at the AgBot Challenge, there were a few of the competitors that were able to get fully self-driving, but there still seems to be a hurdle. So one of our goals is to be able to get that information out there so people can have a self-driving tractor. Any questions about corporate community partnerships, or any ideas that you have, or ways that we can work together?
I don't think it's so far-fetched. I mean, there's the reality of, you know, putting stuff in a bundle and an easy way for people to buy. I think that becomes the commercial side of things. But the core technology can stay open source with people, you know, buying, you know, doing your own sort of DIY or lower hobby grade stuff maybe, or even better stuff if you have it. I think there's still a good balance. I don't think it takes away from that capability and still encourages market.
So now we have open questions and answers, or any projects people want to review, or areas that they would like some help on. Always love hearing from
I'll just
Colin.
make a comment.
Mm-hmm.
I played with the TurtleBot 3 today, and I was able to get the CAN interface to work on it, so I can send it messages and have it send stuff back. So that is possible if anybody has a TurtleBot 3 and wants to try that.
Does it come with CAN out of the box?
Yes, it does. It's got the transceiver built right into the board, so you just have to hook 2 wires up to the board to a connector, and you can hook it up to whatever you want at that point. They don't have any software that supports CAN, but the drivers are there. So it just took like 6 lines of code or something to get it to work after I finally figured it out. So it's not that hard to use. But I keep arguing that we really should put CAN on a desktop computer and just use ROS, and you talk to the robot with wireless, and not put a lot of junk on the robot to have it drive around, because that's a lot of weight. See, I got one of the controllers right here. So a controller is this big and weighs half a pound or so, or maybe a pound, and you don't want to bolt that on your robot, which is, let's see if I can pick that up. So the robot is this big, and you put the controller on that's this big, and then you put a lot of other stuff on, then it starts getting to the point where it's too heavy to drive around with everything on there. So I'm still trying to figure out what would be a good way to attack that. So sometime in the future, I can give an update on that, as what we actually ended up doing. So, and my argument is, if we're just talking to it over wireless, then we could say connect it to the mini tractor sitting over here. We could drive that around. It doesn't really matter whether they're talking to the little one or the big one. They should all talk basically the same way, or we should be able to control them the same way. And I'm sitting here with 3 computers in front of me and 2 mice, and I can't find the right keyboard or right mouse anytime. So I think I'm back to the point where I know where I'm doing again. So I'm currently trying to set up my mini tractor laptops with an access point, so I can log in with my other laptop to be able to control it remotely. So that's what I was trying to do while I was sitting here listening to everybody. So that's all I had to say right now, I guess.
That's good.
Matt, you mentioned help. Can I talk about Husky navigation for a second?
You bet. That would be great to get an update.
So we have, if you haven't perused it yet, Matt put a folder out on G Drive for Ross, and then there's also a folder in there for the lawn tractor. There's a couple of things here, but what I wanted to draw attention to was the steps and what I mentioned earlier, getting a couple of hour investment of going from a blank laptop to having raw software installed and testing. I mean, these are the steps that I was going through. So install the ROS on the laptop, get TurtleSim and drive TurtleSim with a gamepad, install TurtleBot, although that may not necessarily need to be done. And then install Husky is all the software simulation side of that. The struggle at the moment is, I mean, ClearPath Robotics has a, let me see if I can make this a little bit bigger for you. ClearPath Robotics has a package, or actually a series of packages all around the Husky platform and driving it in an external environment with GPS. So we've got that to run and to work. There was a couple of fixes that we needed to implement in order to get it to even boot up, and now it's booting up, but we're still getting a series of errors. So at the moment, if somebody were to say, how can they help, it would be to figure out how to find time to, I'm getting a teleop process died, and I think that's causing all kinds of issues later. So I'm wondering if it's expecting, I have to go back and check the Husky packages and see if it's expecting teleop to have been installed previously, or to find the dependencies. There's a way to run a dependency check, I think. Anybody knows how to do that and wants to share that right now, that'd be great. Otherwise, that's where we're at the moment with getting the Husky navigation to work.
I think there's a command called ROS-dep.
Yeah, as I was saying that, I just remembered that.
I'm typing on the wrong keyboard again.
So anyway, there's also instructions here, just while I've got the floor, to load up the Ubiquity package, or actually the whole ISO file on RPi 3, and then also with Matt's help, we documented the accessing, remotely both the companion computer of the RPi and somebody remotely. I just want to pay homage a little bit to, there's a particular section in here about understanding your joystick. And, it's a little, I'm having a little bit of a go at Matt because he was complaining arduously about how long it took me to figure out, what button triggered, the number 6, the number 6 button on my joystick. But, he had one from Walmart. I had a Logitech. And so I think the problem was with his Walmart joystick, not my Logitech joystick, but I digress. Anyway, pretty detailed instructions should anybody want to jump in and embark on that little journey.
Well, the error message, the process has died with the exit code -11. Did you figure out what was causing it?
Not yet, Matt. I stopped spending time on that and spent time on the VPN thing and remotely interacting with Matt, so I just ran out of time.
Yeah. So interestingly, that's just probably the second time I'm looking at that. With that error message, they say sometimes there are like obviously a few reasons, but the one that you wanted to look at, it's the parameter initialization, or the somehow you're calling the parameter through the node or the program that's already not kind of initialized or existed. -11 is basically also comes up when your code has some problems. It means that you're like you need to debug basically, check the log file. But chances are there that your one of the hardware connections is not making a contact or not getting the data in. That's when it's trying the fire up that through the launch file, and it would not start. So take a look at the parameters in the log file. That actually it may give you some clues. Also, the extreme cases where if you have the ROS installed recently, or if you had some update that happened over the auto update, obviously the ROS pushes out all the packages, and if you're running on the Kinetic. I had a problem last week where none of my autocomplete would work. And as soon as I try and launch our ROS run or even the ROS launch, it just would not go anywhere. Although the nodes fire up and everything else worked. So I had to completely reinstall, I had to get rid of the whole Kinetic packages and completely reinstall the ROS. And after that, started working. So that's the extreme case, but you might want to start with the check the parameter initialization through the launch file, because that's one of the major reasons that it would die on you when Nano would just come up with that error message with the exit code like -11.
Thanks for that, because I'm wondering if they may have expected a joystick to be plugged in, because I don't think I was just doing purely simulation, right? There's no physical hardware, so I'll that's a good suggestion. I'll go check that. Back over to you, Matt.
Thanks, Al. Colin, what's happening down there? Over there.
Nothing special.
Nothing special. You pass all of your tests. Are you ready to start on physical hardware?
Yeah. I think for me, I've resolved that I need to get to understand most of the things before I start on my lawnmower. I spent this week, I've covered, I had to go back to cover issues to do with Arduinos again. And I worked on what they call the Pi board, which allows you to program your Arduino using the Python programming language. So that's the stuff for now I'm going through. I become jealous when I see you guys talking with confidence what you're trying to do. Your issue is that the components are either not talking or running smoothly. Mine is getting to know how to get the components to work. The next will be where to place the components on the lawnmower itself. So I don't want to rush into working on that lawnmower and then be stuck both from a knowledge point of view and people once say that it's one thing to have zeal, but it's dangerous not to have knowledge. So once I feel that I'm confident on what I'm trying to do, I'll be updating you accordingly. But for now, I decided that I need to know what all this mean. I will not drag the team back by asking questions anymore. I know our last time said to me, we can't take your question, even though the time was not up. So I realize I may draw the team back, but I'm enjoying listening to what's going on. So expect not too much from me for now.
We'll keep checking on you.
It's all right, I don't mind.
Anybody discover an interesting ROS package this week? There's a list that comes out with ROS, which all of the packages are released for the different versions. But then there's also probably twice as many packages on GitHub, and then maybe a quarter number of packages on Bitbucket.
There is apparently an interesting course that in ROS that has been set up by a doctor called Annie through ROS. It's quite interesting. It's one of the courses I'm taking with him. And yesterday he added another part. I think he communicated through ROS. You must have seen it.
I saw that he posted a new tutorial on, I think it's URDFs or something. Yeah. Is that through?
Through Udemy.
Okay, perfect.
Through Udemy, yeah. It covers most of the things that we talk about in the community meetings. But it's still at the initial stages. It's helping me at least to understand what ROS is all about and what we are trying to achieve as ROS community.
Speaking of ROS2 and package updates, the Lino robot, Juan, he says they're working on switching Lino robot over to ROS2. So that'll be pretty interesting to watch that switch. I haven't moved the lawn tractor over to Lino robot yet, but I've been thinking about that just for ease of installment. If we team up with Lino robot, then you have all of those motor controllers and all those sensors already built in. We can extend it to add the GPS, and then everybody can have a nice tutorial on how to get their robot, how to tune all of the PIDs, how to get everything running. And then if they're doing the work to migrate up to ROS2, that might be a good project to stay on top of.
Yeah. I think it's a crucial question, Matt, that we should address. Should we continue on ROS1 or go straight to ROS2? Because ROS1 will soon no longer have support.
Yeah, but that's like 2028.
Yeah.
Yeah.
So I think if we start thinking about ROS2, it will probably be the best thing to do.
I agree. I don't know when to make the switch, but maybe it'll be next year, but definitely some components will start to come online where you want to run ROS2. And maybe that means there's 2 Raspberry Pis, one Raspberry Pi running ROS2 and one Raspberry Pi running, or whatever computer running ROS1. But you can have multiple nodes. You can have ROS1 nodes and ROS2 nodes. So I don't know for sure, but I think going forward there'll probably be a little of both for a while.
Yeah. Can I ask a question on Arduino? I've noticed that you end up having on some of the websites I've seen, you end up having two Arduinos connected to an automation. Is that because you've run out of the points to connect, or it's because the two Arduinos can be necessary to have on your project? Does it make sense?
Yeah, anybody have any ideas on that?
My thought is that it could be either situation. If you start off with a small Arduino and it's only got 13 pins or something, you may run out of enough pins to control what you want to do, or you may need multiple peripherals of a certain type. Maybe you need 3 UARTs and maybe your board only has 1 UART. So then in that case, you need to go to a second board to do that. Or it could just be, a lot of times it's easier to write your software on one board, and you want to write something else, it's easier to put it on a separate board instead of trying to merge the two pieces of software together. So that there's various reasons why you might want to go to multiple boards. So you just have to look at each case and decide if that's what you wanted to do or not.
Well, why don't we use registers? Because you can have more registers that are linked to Arduino, and then it helps us to avoid having to run out of pins. Process registers.
Sometimes it's just easier to, instead of adding on like a shift register or something, or a latch to get more pins, it's just easier to put a separate processor on there instead of having, instead of adding on your hardware and adding on, it's just easier to grab another board that's already got a processor and you just write your code. And so sometimes it's easier to do that. Sometimes it's easier to expand the hardware. And again, it just depends on what you're trying to do and what you have available at the time, or possibly your experience level. If it's, it might be easier to do it in one way or another. And especially if you're following someone's tutorial, they say to do it a certain way, it's easier to follow that than try to figure out how to do it some other way too. Does that answer
All
your
right.
question?
It does. It does. The reason why I needed to get that explained is because in one of the tutorials, what we were doing was we were using the registers to compile a program. We had gone through the whole process of binaries, pluses and ones and zeros and so on, calculating the binaries for uppercase words, lowercase words, and individual names. Now we had taken that whole tutorial to the breadboard, where we ran out of pins for Arduino, and the suggestion was that we could use another Arduino to augment the number of pins we wanted. But we ended up resolving to use the registers. But the registers, I think for purposes of learning, we had now to code the registers, because they are blank registers. Now you need to compile so that they are able to read the pins and communicate with other registers, so that you end up with as many pins as you want. And I was figuring out, well, I was wondering whether you guys, with the project that you have been doing, you faced any situation where you wanted to have two Arduino boards. You answered that question. Thank you very much.
I also find that if you start with the small Arduino board, you're going to run out of room at some point. you know, as you start adding stuff on, you're going to run out of room. And then next time around, you're going to buy a bigger board that just has more pins to start with and has more capability. And that's why I keep talking about these other boards that I'm playing with. You know, I've got some cases where I got the little, in fact, here's one right here that's I got the little Arduino board like that I'm using. I had it hooked up to a sonar. But then in other cases, I want to use these big boards that have the, like the one I was showing last time, where it's got, you know, it's got like 100 pins on the board that I can hook up to. So basically, you know,
100 pins.
it's something like there's two rows of 50 pins on that board. So there's a lot of pins on that board, and not all of them
That's
are.
expensive.
It's a $20 board, so it's not, the board's not real expensive. It's not much more than an Arduino, and it's about the same price as the Arduino Mega probably. But again, it's not the standard Arduino, so you can't go out and just grab somebody's code and drop on it. So that's another thing you have to look at when you start looking into the bigger boards, whether or not you're going to get the information available. It's nice to have a standard Arduino because you can go out and, you know, there's thousands of sample programs you can run on it. But if you get a bigger board, then all of a sudden maybe you can't find the example code that you need to make it work. So there's a lot of things you have to look at when you start picking something different. That's why it's good to start with the Arduino that has lots of examples and it's documented very well. And as you're going through step by step to figure out how to do these things. And then eventually you can say, oh, well, it's too small or it doesn't have enough pins. And then you can think about getting something bigger at that point.
Thank you very much.
That's excellent. Well, we've reached the top of the hour. Thank you guys for being here. Howard, great seeing you. That's where I'd jump off, but it's good seeing you guys. Have a great week.
Thanks, guys. Thanks, Matt.
See you guys.
Okay, goodbye.
See you all.
Thank you.